Next chapter. Going on to motor controls. This is the actual controls. I'll get them in a bit. Wrong way. This is describe manual magnetic starters. Manual or magnetic starters. The manual would be the switch. The magnetic would be like the motor control relays I have at home. List code requirements for motor controls and motor control circuits. Oops, got one. Determine the proper and overcurrent protection and conductor size and control circuit. Identify several types of pilot devices. Read control circuit diagrams. Reverse motor direction by switching connections. Describe the basic motor control center setup. Okay, this would be a manual switch on off position. It also gives you a chance so you can lock it so nobody turns it on, compared to something like this. They do make lockout devices where you can lock out a switch. I showed you all in my lockout device, and I don't think I have it here, that you can put over, so that way if you're working on a piece of equipment, turn power off, lock the switch off, nobody can turn it back on you. This is your safety precaution. Alright, motor control circuits. The motor controller, let me get back a little bit. It says, to make practical use of motors, they must be controlled. Control can be accomplished by many methods. A snap switch can control small motors. Large motors use more complex controllers, require programmable sequence. In addition, some motors require reducing voltage control or reversibility. Okay, so before I get into that, in addition, motors require reduced voltage control. So again, sometimes your voltage may be 12, 24, 48 volts, 120 volts. So a lot of times they're usually about 120 volts. I have those transformers. I have one that's 36 volt. One of the controllers that I have at the school, that's 36 volts. There's a transformer. So your power comes in. The one I have, the transformer I have is a 4 voltage is a 120, 208, 230, 460 volt transformer. So no matter what the applied voltage is, I can use any of the applied voltages, knock it down to 36 volts and feed the controller. Okay. In addition, some motors require method of reduced voltage, the others reversibility. You know, you have a piece of equipment and you have to turn it on and it moves forward and then it goes in reverse. I'm just getting some things here. In order, thinking we were going to be in class, and I was limited on what I had, so I went out and bought so we can do the hands-on part on motor relays. So some of the things I got was the base for the relay. So this is they call it an ice cube relay. It's still a relay. Yeah. It's got a timer on it. So if you want to set time, don't come on when I push the start button. You know, come on when, you know, give me a 10-second delay, 20-second delay, 30-second delay, whatever it is. That's what this does. Okay, and the base goes in here. All your connections of your wires go right down in here. Okay. So I have bought these all in preparation. And then these are simple relays. Okay. So you can see brand new, taking them out of the packages. This is our relay. So it has my L1, L2, L3, so it's my power coming in. And then number 13, normally open. Number 14, normally open. Down here I have my A2, my A1. My A1 would be my neutral. This is a 120 volt coil. This is a 120 volt coil, so my A1 would be my neutral. I have A2 on this side and I have A2 on this one, but I have number 3 and number 4. And down at the bottom I have T1, T2, and T3. So my line comes in, my motor controller, my power goes out. So I have the stop start switches. So I have my stop start switches. So obviously green go, red stop. These are a little bit different. So you can see it has a, where my switch contacts are down here, and this part is a LED light. So these up here is for the light, down here is for the switch. On this switch, on one side it says 12 and 24, and on the other side it says 11 and 23. Okay, so the numbers, when I said earlier, had the 13 and the 14. Guess what? Some come 13, 14. So that's depending on the manufacturer is what you get. This here would connect to my T1, T2, T3. So this would go here. Let me get my Phillips screwdriver here. So this would connect to my controller. Now this is my overloads. These are my overloads. Okay, so my motor, instead of coming out from down here, would come off of here. And then my normally opening and normally closes up here. You have to have that in series, tied into here. So if this trips out, that's what the red button's for. So if too much current goes through, this will trip out, and that's what protect it. It has a little dial. You just open it up and set it at whatever amperage that you're, when you get the service factor, multiplied by either 115% or 125%, that's where this goes in. Okay, so this is the relay, and these are your electronic overloads. So they're electrical instead of being fixed ones like I have in the classroom. This is an electronic one. Okay, I also have the one starter in the back that has an electronic one like this that you would set it accordingly. So these are some of the different components that we use on our sizing of the circuit. Not sizing of the circuit, I'm sorry. Wiring of the circuit. Whether it's an ice cube relay, time delay relay. My ice cube. Okay. So my motor controller. This one is small, it's for smaller motors. My stop start switch. Okay. Different things we use. So what does the starter do? It regulates the power supply to the motor. The motor controller is a device that regulates the power supply to the motor. A number of different devices can be used to do this. Contacts within the controller open or close the motor circuit, thereby starting or stopping the motor. Okay, motor controllers are often referred to as starters. Starters are rated for motor horsepower and has a rating system, and then it says the NEMA, the National Electrical Manufacturers Association, NEMA, has a rating system for starters with numbers ranging from 00 to size 8. So this is a 00. Up in the classroom I have a size 0, a size 1, and a size 2. Okay, so that big one that I always pull out, that's a size 2. Okay, this is a size 00. So again, starters come in different. And then when we get these, it is rated for motor horsepower and full load currents. So this one has horsepower at 220 volts. It's 12 amps. At 380 volts, 12 amps. At 660 volts, 8.9. So this one does not have a horsepower. So it does have an amperage rating. So you need to make sure that your voltage does not apply this, to pass this up. How do you find, say you don't have, because this here says 220, 380, and 660. Let's say we're using 208. Okay, all we have to do is get that 220 multiplied by 12. It gives us our watts. Voltage times amps gives us our watts. Now we have our applied voltage divided by our applied voltage. So let's say it's 208, or our voltage is 480. We can divide the wattage by the voltage. Now that gives us the amperage. So that would be the maximum amps. Okay. These are basically designed for smaller motors, not bigger motors. Okay, so you have a manual starter and a magnetic starter. The manual starter would be a switch, and a magnetic starter would be any of these. This is a contactor. These are used more, they're not used to carry, these are only carrying control voltage. These can carry voltage on amperage on them. So this one can hold up to 10 amps at 250 volts. And this one can do 5 amps. So again, if you use something like this, you can use it to run the motor, but it's going to be something that has low amperage. Same thing with this one, because they are contactors. It says the code addresses motor controllers in Part 7, Article 430. There are several noteworthy sections. 430, 82A. A starter must be able to interrupt the locking rotor current of the motor, which may be 8 times as large as a full load current. It must also be able to start and stop the motor during normal operations. So when we got that minimum and the maximum, that's where all that comes in. Okay? When we got that minimum and the maximum, that's where all that comes in. I moved the camera, sorry. And I was walking by. And it's section 430.83E. If the conductor has a starting voltage rating of 480 volts, for example, the nominal voltage between any two conductors cannot exceed the rating of the controller. Has a slash rating 120 to 40 volts. So the voltage between two conductors cannot exceed the upper value, and the voltage between a conductor and the ground cannot exceed the lower value. Okay, so in your book, again, it said 480. So if your contactor says 120 to 480, but because it says 120 to 40, hot to ground cannot exceed 120 volts. Okay. But if it says 480 max, a lot of them will say 600 volt max. This one has 660. So depending on the voltage on it, oops. Section 43084, the controller does not need to open all motor conductors unless it is also serves as a disconnect means. So we were doing sizing feeders in the last chapter. So we had a feeder that controlled 2 motors, 3 motors, motors and other loads, it doesn't matter. Okay, this would only control that one motor. This would only control that one each individual motor would have their own starters, and this is what I was talking about. So you have to find the overloads for each individual motor. But you can also put one in to control all of them. You can put one in, okay, I hit the master stop. The master stop stops everything on that line. You know, say I got an assembly line. Something goes bad. I have to have a main area where I can turn everything off at once. Okay, I can either put a shunt trip breaker, where like in the gas stations they have that big red button. You hit that red button, it turns all the power off to the gas station. You can do the same thing with the motors. It just goes to a breaker, turns the main breaker off. Okay, so it's not an overcurrent protection device. Always remember, breakers aren't considered an overcurrent device in the feeder circuit. It's a short circuit ground fault protection. Why? Because if there's a short circuit, it's going to create high currents, because the breaker is going to be either the breaker fuse, main fuse, or whatever we're using. So dual element, time delay fuse, 175, inverse time breaker, 250, and non-time delay or a single element fuse, 300%. Okay, manual starters. Manual starters are the simplest type of motor control. These hand operate on and off switches are used for motors rated up to 10 horsepower. The contacts remain closed in the power supply. So let me go back to that 10 horsepower. Okay, so if you get a motor, I can't use a 15 amp switch. I can't use a 15 amp switch on a 10 horsepower motor, because if I go to find it here real quick. 10 horsepower motor at 115 volts does 100 amps. Okay, well, a 15 amp switch ain't going to be able to handle 100 amps. Always remember that. Okay, so once you get up to a certain point, whatever switch you use has to be able to carry the current of the motor. It has to be able to carry the current of the motor. If power, so the bad thing about a switch is power goes out, that motor will turn off, but when power comes back on, that motor comes back on. If the switch is still in the on position, that motor will come back on. And that's what's talking about. The contacts remain closed when the power supply is interrupted, so the motor automatically starts when the power resumes. It says the motor is rated 2 horsepower or less. A general use AC snap switch can be used as a control as long as the full load current does not exceed 80% of the snap switch design rating. So that's what I was talking about. Okay, so if I got a motor and I'm using a 15 amp switch, the maximum I can put on that is 12, because 80% of 15 is 12 amps. Okay, 20 amps, 80% of 20 is 16 amps. So if I had a 20 amp switch, guess what? They make them in 30s also, and they make a motor minder switch or a motor rated switch that can be used, and that's the one that's the let me see if they have it on here. No, it's the wrong way. Here's a code alert motor controller section 430.2. Any switch device normally used. This question was in the last test, not in this one, but that's something I drew up just to get your minds going. Yeah, we did talk about these suckers in residential wiring and your electrician too. All right. So there is a manual starter, hand operated, on and off. Switches motors rated up to 10 horsepower. Motors 2 horsepower or less can use an AC snap switch. Okay, this one is a 3-phase switch. So these are designed for a 3-phase motor. They make it for single phase. They make one that has can take an overload inside. There's all kinds of things. Yeah. All you gotta do is Google manual motor starters. Yeah, a lot of things will pop up. Let me see if I have one here. Let me look in my goodie box. I don't remember what else I bought. I bought all kinds of things. I was going to be prepared. Here's another stop start. Okay. Green button on. Off. Okay. 3-phase motor. L1, L2, L3, T1, T2, T3. So that goes to the motor. Power comes in here. Goes out to the motor from here. This is a 15 amp. 10 amp, I'm sorry. This is a 10 amp switch. So I couldn't put more than 10 amps. At 220 volts. 220 volts, no more than 10 amps. This is a 220, 380 volt, 10 amps. So if I had a 277 volt, 277 480, I couldn't use it. Okay, hot to ground. If I use a 277 480 Y system, okay, hot to ground is 277 to ground, each hot. Well, my lower voltage is 240. Okay, so that's another type. I wonder if I get anything else in here. I think that's it. Yeah, I bought 2 of those switches. Alright. Motor starters. The magnetic starter, commonly called a motor starter, operates using electromagnetism. An iron core with a controller is wrapped in a coil of wire. It says when the current runs through the coil, the core becomes magnetized. The armature is attracted, and the armature moves forward in the core. It closes the contacts, allowing current to flow. As long as the coil is energized, the armature is held, the contacts remain closed, and the motor continues to run. When the power to the coil is stopped, the core loses magnetism, the armature returns to the resting position, and the contacts are open. So when we use any of these here, so this one is called a clapper, because that's how it's working. Vertical, going up, making contact, horizontal, going that way, and then the bell, because the backside, right back here, here's my coil, here's my magnetic, just like a transformer. It has that iron core that goes around it, and then this is metal and this is metal. This becomes magnetized, and this core, this metal part here, boom, comes up. When this comes up, it pushes that in, and that's how it goes across. The clapper the same way. Okay, here's my coil, here's my iron core, my magnetic field. So this is my core. My metal core is right here, like an E, with my coil. So what happens is, this is metal. When this becomes magnetized, boom, it closes, makes contact, power's in. Now power goes through here, comes across, and goes out. Same thing here. Here's the same thing. Okay, as this becomes energized and creates a magnetic field, turns this into a magnet, boom, it pulls this up. As it pulls this up, this makes contacts here. And same thing here. Here's my core, here's my coil, and then boom, this closes, so it pushes it that way. The one I have would be, I would say, something like, well, it's clapper, vertical, horizontal. Mine's a vertical, but it's upside down. So it goes down when it makes contact and it comes up. Same thing with this one. Okay. This blue part right here, that's where my contacts is. It's got a spring in the back. It's got a contact, and the coils around this blue part, as it becomes energized, this gets sucked in. And as long as there's power on that coil, that stays in the on position. Once it loses power, boop, it opens up again, and it cannot reclose. So once it loses power, it's open. The only way it's going to start again is if I go over there and I push the start button. And we'll get into the wiring in a bit. The contacts are copper or silver plated metal. Maintenance of the contacts is fairly simple. They require periodic cleaning and realignment. It must be replaced when they become worn or burned. Magnetic start also contains integral overload relay. The relay can be thermal, magnetic, or solid state. A thermal relay can be either biomedical or consist of melting metal alloy. Magnetic relays are also two common varieties: inverse time and instantaneous trip. Solid state relays are sealed unit in the current sensors through which the current. So this is a solid state one right here. So our relays, this is a solid state. Okay, this is a solid state. So this is sensing that current that's going through. It's like an amp probe. It's reading that current. And whatever I have the setting at it, when it exceeds the setting, whoop, it opens up. And then once this opens, because this is tied in series with this, so once this opens, it removes power going to the coil. Okay, because I'm going to have my stop and my start, and we'll get into that in a bit. Okay, so this will take the power off from here. How do you reset it? You come over here. If this trips out, you hit that red button. It resets the inside. You go back and boop, hit the start button. You walk back and go to the start button. Now you can turn your motor back on. Okay. If it trips out and it's not this, if the breaker trips and the solid state doesn't trip, and then something else might be going on. Into that in a bit. Okay, motor control circuits. Power for the magnetic start is supplied by a motor control circuit. This circuit is supplied separate from the circuit supplying power to the motor. The conductors used in the motor control circuit normally originate at a service equipment or taps into the line side of the power supply. Okay. Control circuit. Control circuit. Circuits of a control apparatus, a system that carries electrical signal directing performance of the controller, but not the main power current. I'm not going to get into that right now. Okay, so here this says separate carry lower signal current to direct function of the controller rated at 120 volts or less. So again, this coil is 120 volts. So I would have to apply 120 volts. My voltage would have to be a 120/208 or 120/240, single phase or three phase, because I can do all three hots. Okay, so this is how that would work. Okay, again, if I was using a 120/240 three phase, more likely that's a delta. So I just got to make sure that I'm not going to tie in to line 2. I can always come off of line 1 or line 3, come over, go to my switches. If I have relays, time delays, or whatever else that turns on things, and then I would come back to here, my start stop, and then it comes back to here. Okay, so anytime I hit the start button, it turns this on. When I hit the stop button, it turns this off. Okay, so I can either pick it up from here, from the motor, as long as the voltage is present on the coil. I have one at school. One of them is a 220 volt coil, and then the other one is a 120 volt coil, just like this. So if I have 220 volts at the coil, boom, no problem. If my motor is I got 220 volts as a hot, 240 volts as a hot, because I got a 240 480 system. Well, I can take 2 hots off of there. No neutrals needed, because I'm going to bring a hot to A1. Okay, A1, it's either a hot or a neutral. And then my 3s and my 4s are the ones that get the other hot. So one would come into one side of the coil, and the other one would come into the other side of the coil, whether it's a hot and neutral, hot and neutral here, or a hot here. But you're going to have, I'll stay with a 120. So I would have my neutral come in here, and then my hots are tied over here with the A2. I got an A1 and an A2. So after I put everything in, tie everything in, okay, that's how my motor's going to turn on. Because this is my coil, A1 and A2. A1 is my neutral, A2 is my switched off. So in your book on page 203, down at the bottom it says a magnetic starter. So you can see that magnetic starter, that the contacts are at the base, at the back. I wish I would have had it up here. They would have had it in the PowerPoint, but they don't. So I was looking for it. Let me go a couple more. No, they just got the wiring. But on page 203, down at the bottom, figure 14.3, a magnetic starter with thermal overloads. So you can see your overload is at the bottom. This one is either, this is a thermal overload. Those are the heaters that I take out and send around. Okay, and on the right side, it shows the stationary contacts. So it is so you have the picture on the left, you have the actual picture of the contactor. And then on the right you have a single line drawing of the contactor. So you have the contacts, the overloads, and then the bottom at the you have the 3-phase motor, and you have the T1, T2, T3. That's what's going to the motor. Up on top it says your power circuit wiring diagram. So up on the top where the stationary contacts are, that would be your L1, L2, and L3. Okay, I'm going to send this, you'll be getting this once you get it. Okay, I'm also going to be sending some questions, an assignment with this video. So I will be sending an assignment with this video. That's due by tomorrow morning. Oh, I'll take it back. Today's Thursday. Due by Monday. Due by Monday. As soon as you get it done, you can send it to me. Alright, y'all have a beautiful weekend. And see you again on Monday.